Welcome to your geometry recorded session for the week of October 20th. And we are in week 10. So this week when you go to do your assignments, make sure you're looking for the assignments in week 10. And let's go ahead and take a peek at what we're going to be doing this week. So this week we are finishing up Unit 2. So we are wrapping up our exploration about triangles in Unit 2. So this week the last session that you're going to complete with new content will be Unit 2 Session 11, where you're going to learn about the mid-segment of triangles. So last week we talked about different segments within triangles. We talked about perpendicular bisectors, we talked about altitudes and medians. And this week the last segment that we're going to talk about that occurs in triangles are mid-segments. And then you're going to do some reflecting on Unit 2 and then take the Unit 2 test. So before we move on to some new content this week, let's talk about things that we have learned about in Unit 2. So Unit 2, we know, was all about triangles. We really focused on triangles. We started the unit off with talking about transformations of triangles, or transformations of really all sorts of different things. But transformations, so we talked about translations, dilations, reflections, and rotations. Then we moved on to triangle congruence and how we can prove that two triangles are congruent. So remember, in order for two triangles to be congruent, we talked about how all corresponding sides of triangles, so all corresponding sides would have to be congruent, and we can use different number of ticks to show that our corresponding sides are congruent, as well as all corresponding angles have to be congruent. So really we talked about how there are 6 different things, 3 sets of sides and 3 sets of corresponding angles have to be congruent. So there's 6 different things that has to be true to prove that triangles are congruent. And that's when we were introduced to some shortcuts in showing that triangles are congruent, where we only need to find 3 things to prove that two triangles are congruent instead of stating all 6 things. And that was the side postulate, the side angle postulate, the angle side. Which one am I missing now? Angle, side, angle. And then when we have 2 right triangles, we can use the hypotenuse leg. So these are the postulates that we learned about that we can use to prove triangles are congruent. And it's a shortcut for us. And then once we've proved that 2 triangles are congruent using one of those postulates, once we have proved that 2 triangles are congruent using 3 different aspects, whether it be corresponding sides are congruent, side, angle, angle, side, angle, and hypotenuse leg. Once we've proved that 2 triangles are congruent, we know then that all corresponding sides and all corresponding angles are congruent. I guess I could go back down to this here. And that is when we can use the CTC postulate, where it says congruent parts of congruent triangles are congruent. So once we've proved that 2 triangles are congruent, that's when then we can use this postulate to prove that any other corresponding legs or any other corresponding angles are congruent. And then we got into Unit 2, as I talked about a little bit earlier here, all the segments that we learned about. We learned about perpendicular, I'm going to go up to the top of the screen, perpendicular bisectors. We learned about altitudes and medians. And then today, in a moment, here we're going to learn about mid-segments. So that is a crash course on what we learned about in Unit 2. So I have a warm-up question that is actually from a question from your Unit 2 Session 8, number 6 assignment. So on the Unit 2 Session 8 assignment number 6, I had some questions about this problem, so I thought I would go over it today with all of you guys. Hopefully it will answer any questions you had about this problem. So what I want to do first is look at the problem, and we need to solve for x. So we've got one angle. So this angle, let me do that in a different color here. This angle right here is labeled with, it's represented by 5x plus 15. And then we've got a bunch of ticks, and we are asked to find x. So what I want you to do is focus on the triangle on the left-hand side. I'm going to highlight this triangle in yellow. What type of triangle is that? This is an equilateral triangle. We've got all sides are congruent, so it's an equilateral triangle. What do we know about the angles in an equilateral triangle? They all have to be the same because all the sides are also congruent, so all the angles also have to be congruent. So we can figure out really quick how many degrees are in each angle of a equilateral triangle, because we know all triangles have a total of 180 degrees, and if each angle has to be the same, and there are 3, we would just take 80 divided by 3, and that would give us 60 degrees. So in any equilateral triangle, you're going to find that all the angles are going to be 60 degrees, since they all have to be equal. So we can label each angle as 60 degrees. Okay, so that's going to help us when we look at the other side of the triangle. So the right side of the triangle, what type of triangle is that on the right-hand side? So I see that there's a tick on this leg and there's a tick on this leg. So that means 2 legs are congruent. And when we have 2 legs being congruent, we know that that is an isosceles triangle. So the triangle on the right side is an isosceles triangle. And how many angles, so we know in isosceles we've got 2 sets of congruent legs, and we know that the angles opposite those set of congruent legs are going to be congruent. So that means that these 2 angles that I'm highlighting in blue have to be congruent. Therefore, I can go ahead and label this angle also has to be 5x plus 15, since those 2 angles have to be congruent because they're opposite the 2 congruent legs. So we're almost getting closer to be able to set up an equation to solve for x. We're just missing something to label this angle with. We don't know what this angle is. But look, we know what the adjacent angle measurement is. We know that this angle on the left over here, the adjacent angle is 60 degrees. There's a straight angle. There's a straight line that makes up these 2 adjacent angles. So how many degrees are there in a straight line? Do you remember how many degrees are in a straight line? There are a total of 180 degrees in a straight line. So if we know that 60 degrees are already being taken up in that straight line, that's going to let us know 180 minus 60 is 120. So we know that this angle measurement here would have to be 120 degrees. Now we've got enough information to set up an equation to solve for x. How many total degrees are there in a triangle? There's 180. So let's go ahead and add this angle to this angle to this angle and set it equal to 180. So I'm going to change colors here just so that we can set that up, we'll do red here. So we want to do 5x plus 15 plus 5x plus 15 plus 120 equals 180. So all of our like terms on the left side, let's start combining those. 5x plus 5x, that's 10x. 15 plus 15 is 30 plus 120. So 30 plus 120 is 150. And then we set that equal to 180. Next step is to subtract our constant term from both sides. We're going to take away 150. So we get 10x equals 30. Divide each side by 10, divide each side by 10. X equals 3. And we are done. All right, I'm going to go to the next slide, so if you need more time to write down some notes, go ahead and do that. But we're going to go on and learn about triangle mid-segments. Oh, just some reminders. Use your catch-up days to get caught up. Remember, I always do a suggested pacing guide throughout the week. Go ahead and print that document out, and it's got some catch-up days in there for you. Take advantage of those. A great way to review Unit 2 is to redo low-scoring assignments before you take the Unit 2 test. Remember, if you do redo anything, you have to send me a message. If you submit any late work, you have to send me a message. Otherwise, it's not going to get graded. And then again, this is also the last week to redo assignments from Unit 2 since we are taking the Unit 2 test. I will allow you to redo what assignment? We are doing the Unit 2 Session 11 assignment this week. So I will allow you to redo that next week. That will be the only one. And that's because I'm assigning this week and I won't have it graded till next week. So that's the only assignment I will allow you to redo next week. Okay, so the mid-segment theorem. So the mid-segment is a segment that joins, a segment that joins the midpoint of two sides of a triangle. The segment joining the midpoints of two sides of a triangle is parallel to the third side. And the length is 1/2 the length of the third side. So what does that mean? So the mid-segment, here's an example of one in green here. It's about halfway, it's going to be halfway between your vertex and the bottom leg of your triangle. So if you look, the mid-segment divides each side into two equal parts when it bisects it. So that's why I said that the mid-segment is halfway from your vertex to the bottom leg here. And you can see that when we draw it in, again, that it bisects each side into two equal parts. So when we bisect at point E, it bisects into two equal parts here and two equal parts here. And then there's a cool pattern that exists, is that the mid-segment, so that mid-segment that's green, that green line will be equal to 1/2 of AB, and AB is that bottom leg of our triangle. So so remember, this shorter leg will be 1/2 of the bottom leg of your triangle. The mid-segment will be half of that hypotenuse of your triangle. So let's put that idea to use. So find the length of AB. So AB would be this segment right here. We want to find the length of AB given that we know DE equals 7. So if DE equals 7, what must AB equal? Well, remember, the mid-segment will be always half the length of the hypotenuse. So knowing that, we can think of it backwards, that if we take 7 and multiply it by 2, we'll get AB, and that is what AB is 2 times 7 would equal 14. So AB has to equal 14. And that goes back to what we just learned, that DE is always going to be half of AB. So we could look at it a different way if we wanted to and say that then plug in what we were given, DE equals 7, and it's going to be half of AB. So to find AB, we would need to multiply both sides by 2 to solve for AB in that equation. We would need to multiply each side by 2. Multiply this side by 2 to get rid of that denominator. Multiply this side by 2, and we get 14 equals AB, which is what we did up here. So either way you want to look at it, it makes more sense to you. Use that. Alrighty, so here, now we're just given some equations. We're told that DE is x plus 8, so I'm going to go ahead and label that. And we're told that AC, the bottom leg of our triangle, is 4x minus 12, and we need to solve for x. So let's here set up the theorem, the general statement that we know that DE equals 1/2 the length of AC. Now let's plug in the given equations. DE equals x plus 8. And then we're going to say 1/2 times AC. Well, AC, we were only given an equation as well, 4x minus 12. So I'm going to go ahead and clean up the right side of that equation. We're multiplying each term by 1/2. So 1/2 of 4x is going to be 2x. 1/2 of negative 12 will be negative 6. And that way I just get rid of the fraction in there. And then we can finish on solving for x. I'm going to go ahead and subtract this x from each side. And then I get 8 equals x minus 6. So I'm going to move the equation up to the right here. I ran out of space. Last step would be to add 6 to both sides. Add 6 to both sides. 8 plus 6 is 14. And we get 14 equals x. And we have solved for x. Make sure that you are reading what the equation or problem asked for. Here we were asked to find the value of x. That was it. And we did that. But a lot of times it might say find the length of DE, in which we would have to plug that value for x equals 14 into that equation to find the length of DE. So just make sure that you are answering what the question is asking and not stopping too soon. All right. I think this is the last question I have for you today. It says if angle A, we need to find angle A. We don't know angle A. We do know angle BDE, so we know this angle right here is 50 degrees. Can we figure out what the measurement of angle A is? Well, let's think about this. We know that DE and AC are parallel to one another. We know that those are parallel lines. We also have a transversal. We've got a transversal. This line here, AB, is a transversal. It's intersecting segment DE and AC if we continued those lines out. What two angles are these? Based on if we have this as our transversal, AB, transversal that is intersecting DE and AC, what type of angles are these two angles? They are corresponding angles, and because they're corresponding angles, we know that they have the same angle measurement. So angle BAC, or angle A, would be 50 degrees as well. This would also be 50 degrees because of the corresponding angles, and we know corresponding angles are congruent. Okay, and I believe that's our last slide, so I'm going to go on to the next one. If you need more time, go ahead and click pause. So it's time for our key phrase assignment. We are in the week of October 20th, and I'm going to do 2 questions here. I know I've asked this before, but this is so important to make sure your work gets graded. What do you need to do if you submit late or redo assignments. What do you need to do? And then I'm going to answer and ask another question. Number 2, we talked about triangle mid-segments. We talked about equilateral triangles. We talked a lot of things today, didn't we? So what do I want to ask? Let's do a picture of a triangle. And we're going to label A, B, C, M, N. And I want you to tell me the relationship between segment MN and AC. So tell me the relationship that you learned about that exists between segment MN and AC. And that's it. So I'm going to go ahead and stop the recording. Be sure to let me know if you have questions as you're working throughout the assignments this week.